Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous videos, I was actually explaining the 7th chapter of 9th standard mathematics that was on triangles. So I have already completed exercise 7.1 questions and also examples before that and the concepts which are there before that particular exercise. So in this video, we will look into the next concepts which are there after exercise 7.1. So the next concept which we are going to learn here is we will be looking into theorem 7.2. So in theorem 7.2, first I will write the statement of this particular theorem. So now if you consider a triangle and in that triangle, if angles opposite to equal sides. So here you have to consider an isosceles triangle. So before looking into theorem 7.2, we'll learn what do we mean by isosceles triangles, which you have already learned in your previous class. So isosceles triangle is that particular triangle where two of its sides are equal to each other. For example, if I am considering ABC as my triangle, if AB is equal to AC, so if AB is equal to AC, then this particular triangle is known as isosceles triangle. So now here AB is equal to AC. Now we will look into the theorem. Angles opposite. So in this particular isosceles triangle, angles opposite to equal sides. So here two equal sides will be there. So that means two sides are there which are equal to each other. So the angles which are opposite to those two sides. So first let me complete this particular statement. Angles opposite to equal sides of an isosceles triangle are equal. So here basically what this theorem is stating is that if you are considering two sides of an isosceles triangle which are equal to each other, and if you are considering the opposite angles of those two sides, then those two angles will also be equal to each other. Now in this isosceles triangle, which sides are equal? AB is equal to AC. So that means AB and AC are the equal sides in this particular isosceles triangle. Now you have to consider the opposite angles of these equal sides. Which is the opposite angle of AB? So the opposite angle of AB is this particular angle, that is ACB. And which is the opposite angle of AC? Opposite angle of AC is this particular angle, that is ABC. So these two angles will be equal to each other. So that is what this particular theorem is stating. Angles opposite to equal sides. So here these are the two equal sides and these are the two angles which are opposite to those two equal sides respectively. So in this isosceles triangle, the two equal sides, if you are considering the opposite angles of these two equal sides, then those two angles will also be equal. So that means here already you have to consider. So that means in this theorem already they have given AB is equal to AC. So now you have to prove. So in this theorem you have to prove ABC angle is equal to ACB angle. This we need to prove in this particular theorem. So we will look into the proof. So now we will construct this particular triangle one more time. So we'll take ABC triangle. So I am just writing the smaller triangle ABC. Now draw a bisector for angle A. So let me draw a bisector for angle A. So this is the bisector of angle A, where whenever I use bisector, the word bisector, that divides two things, that divides one thing into two different halves which are equal to each other. So that means this angle and this angle will be equal to each other. Now extend this bisector until BC, and this point you can name as D. Here clearly you can see two triangles are getting formed in this particular triangle ABC. So now for proof we will consider triangle ABC. So in ABC triangle we have AB is equal to AC. So AB is equal to AC, and let us draw an angle bisector. So let us draw an angle bisector for angle A. So for angle A, we'll draw an angle bisector and extend the bisector to touch. So extend the bisector to reach BC at point D. To reach BC at point D. So now we have this AD straight line which is acting as angle bisector for this angle A. So these statements you can write on your own. You need not follow the same exact statements what I am writing here. You can write on your own that we are considering an angle bisector AD which has been drawn from A to D in such a way that angle A is divided into two halves. Or directly if you are mentioning angle bisector, then of course it is understood that it is dividing angle A into two different halves which are equal to each other. So now these statements and all you can write on your own words. So in this particular triangle we have an AD line. So it is dividing this triangle into two different triangles. You can see here. One is ABD and the other is ADC. Here AB is equal to AC. So now we will consider these two triangles. So now we have two triangles here. So one is this particular triangle and the other is this triangle. So this triangle is ADB. This triangle is ADC. So this angle and this angle are equal. This side and this side are equal. So here AB is equal to AC. Since this is an isosceles triangle, you can write that in the bracket. Now here angle BAD is equal to angle DAC because AD is angle bisector. So now you can consider AD is equal to AD because AD acts as the common side for both this triangle. So AD is common side, so AD is equal to AD. So AB is equal to AC, angle BAD is equal to angle DAC, AD is equal to AD. So now here you are getting side, angle, side. So that means according to SAS postulate, so according to SAS postulate, or you can consider axiom, here we have considered SAS as an axiom. So according to SAS axiom, here triangle ABD is congruent to triangle ADC. So now we have proved these two triangles are equal. So straight away corresponding sides and corresponding angles, that is corresponding parts of congruent triangles, will be equal to each other. So that means this angle will be equal to this particular angle. So therefore angle ABD is equal to angle ACD, or you can write this as angle ABC is equal to angle ACB. So this is what we need to prove in this particular theorem. So at last you can write the statement of the theorem once again, stating that hence equal sides, opposite angles of the equal sides of an isosceles triangle are equal to each other. So that we have proved now. So similarly, the converse of this particular theorem is also true, which we will be looking in theorem 7.3. So 7.3 theorem is converse of theorem 7.2. So what does this theorem 7.3 states is that the sides opposite to equal angles of a triangle, sides opposite to equal angles of a triangle are equal. So the same thing we have to prove in the other way. That is, in the theorem 7.2 you have proved that opposite angles are equal to each other. So angles which are opposite to the angles which are opposite to the equal sides of an isosceles triangle are equal to each other. Now they have already given angles are equal to each other. You have to prove opposite sides are equal. So that means here, if I am considering the same triangle ABC, so if I am considering the same triangle ABC, here we don't know whether AB is equal to AC or not, but here angle ABC will be equal to angle ACB. So two angles are getting equal to each other. So now sides opposite to equal angles. So these two are equal angles which we have already considered. Which is the opposite side? This AB is the opposite side of this particular angle, and for ABC angle, AC is the opposite side. So now the angles which are equal, so if you are considering opposite sides of these two equal angles, then those opposite sides should be equal to each other. So that means here you have to prove AB is equal to AC. Now we will look into the proof of this particular theorem. So again here you have to draw a particular triangle ABC. Again you can draw an angle bisector. So statements you can write on your own. So for previous theorem itself I have written the statement. So similarly you can write the statement on your own that let AD be the angle bisector for angle A, and here we are obtaining triangle ABD and ADC. So now consider triangle ABC. So here AD is angle bisector. So AD is angle bisector of angle A. Now in the theorem we have already stating that two angles are equal to each other. So that means here this particular angle and this particular angle are equal to each other. So here already in theorem they are giving, already in the theorem we have angle ABD is equal to angle ACD, or here you can, in the place of D, you can write ABC is equal to ACD, or you can write this as angle ABD is equal to angle ACD. So this is already given in the theorem. Now angle, so here this particular angle BAD and DAC, these two will be equal because AD is angle bisector of angle A. So that's why here BAD angle will be equal to DAC angle, because AD is angle bisector. So here AD is angle bisector. So BAD will be equal to angle DAC. Similarly, AD will be equal to AD, which we have already said in the previous theorem, because AD is common side. So AD is common side. So here, before writing this, you should write consider. So here we are considering triangle ABD and triangle ADC. So in that, angle ABC or the angle ABD is equal to angle ACD, and angle BAD is equal to angle DAC, and AD is equal to AD. So that means, therefore, according to angle side theorem, so according to angle side theorem, here here triangle ABD is congruent with triangle ADC. So therefore here AB will be equal to AC. So this particular AB will be equal to AC, because according to ASA theorem, triangle ABD is congruent with triangle ADC. So triangle ABD is congruent with triangle ADC. So that's why AB is getting equal to AC. So this is the proof for theorem 7.3. So now we have proved theorem 7.2 and we have proved theorem 7.3. So now we will look into few example questions which are there here. So now we will look into example 4, which is there in this particular chapter. So in example 4, you have a particular triangle. So let me draw that triangle. So you have this particular triangle. So the name of this triangle is ABC, and there is a line where this angle is 90 degree and this angle is also 90 degree. So this point is D. So now here in the question what they have given is, in this triangle ABC, AD acts as bisector of angle A. So they have already given AD acts as bisector of angle A. So that means this angle will be equal to this particular angle. And they have also given that this particular AD is perpendicular to side BC. So that means this angle is also equal to 90 degree and this angle will also be equal to 90 degree, because BC is a straight line. Now we have to show that this particular AB is equal to AC. So we can just straight away prove that these two triangles are congruent, that is ABD and ADC. So now we will consider, triangle ABD and triangle ADC. So in this triangle, BAD angle is equal to DAC angle. This is because AD is angle bisector. So AD is angle bisector of angle A. Now ADB is equal to ADC because BC is a straight line. So and AD is perpendicular to BC. So ADB will be equal to 90 degree. ADC will be equal to 90 degree. So both of this angle will be equal to 90 degree. So this is already they have given in the question. Now AD is equal to AD, because AD is equal to AD. This is because both are common side. So here AD acts as common side for both the triangle. So now we have two angles equal to each other and one side equal to each other. So that means according to AAS theorem, so therefore according to AAS theorem, here triangle ABD is becoming congruent with triangle ADC. So triangle ABD and triangle ADC are congruent with each other. So therefore AB is equal to AC, because triangle ABD is congruent with triangle ADC. So straight away we have proved AB is equal to AC. So and also they have asked prove this particular total triangle, that is ABC triangle, is isosceles triangle. Because AB is equal to AC, therefore here triangle ABC is an isosceles triangle. This is because AB is equal to AC. So now we have proved this particular example 4. Now we look into the next example in this section, that is example 5. So in example 5 also they have given one figure. So let me draw that particular figure here. So you have triangle ABC and there is a line CE and there is one more line BF, like this. So now E and F are respectively the midpoints of equal sides AB and AC. So that means here already they have given AB is equal to AC, and they have given E is midpoint of AB and F is midpoint of AC. So that means here AE is equal to EB and AF is equal to FC. So now based on this data, you have to prove that BF is equal to C. That is, this particular line BF should be equal to the line EC. This you have to prove. So in solution, what you can consider is that you can consider triangle ABF and you can consider triangle EAC. That is, here I'll write these two triangles separately. So one triangle is there like this. So one triangle is there like this. So this triangle is AFB. Now you have to consider one more triangle, that is this particular triangle. So here we have one more triangle like this. So this triangle is AEC. That is, basically we are considering this triangle AEC and this particular triangle AFB. So consider, here we are considering two triangles. So consider triangle AFB and triangle AEC. So now in this triangle AB is equal to AC, which they have already given in the data. Now here angle A is common, so BAF is equal to EAC because they are common angle. So this angle acts as the common angle for both the triangles. Now we have to prove this particular AF is equal to AE. So before that we have this data, that is AE is equal to AB. So here AE is equal to EB and E is the midpoint, exactly the midpoint of AB. So that means here you can write this as AB is equal to half AE. Similarly, here F is the midpoint of AC. So AC you can write as half AF. So that is this particular line EAF, half AF. So AB is equal to half AE, AC is equal to half AF. Now AB is equal to AC. So that means here AB is already, so if you call this as the equation 1 and if you call this as the equation 2, we know that WKT means it is, we know that. So we know that AB is equal to AC, which is already given. So that means here LHS are becoming equal to each other. So therefore half AE will be equal to half AF. So remove this 1 by 2, because if you bring this 1 by 2 to RHS, it will become 2 by 1. So 2 by 1 into 1 by 2, 2 gets cancelled with each other. So AE will be equal to AF. So now we have proved one more side as equal to each other. So that is, this particular AE is equal to AF. So that means side, angle, side. So according to, so now what and all things we have got? AB is equal to BC, AB is equal to AC, which is already given, and angle A is equal to angle A because common angle. Here angle A is common angle for both the triangles. Now we have proved that AE is equal to AF, which we have proved. So therefore triangle ABE is equal to triangle ABF is congruent with triangle AEC. So because triangle ABF and AEC are congruent with each other, here this particular side BF and EC will be equal to each other. or here BF is equal to C. This is because triangle ABF is congruent with triangle AEC. So this is what they have asked to prove, and we have proved. So now we will look into example 6. So in example 6 also you have one particular diagram. So let's draw that particular diagram over here. So here you have one triangle ABC, and you have two lines coming from the angle A like this onto BC. So this point is D and this point is E, and the data which they have given is AB is equal to AC. So here ABC is an isosceles triangle. So AB is equal to AC. So that is what they have given here. So AB is equal to AC. And here D and E are points on BC such that BE is equal to CD. So that means this particular line BE is equal to this particular line DC. So here we have BE is equal to DC. So now we have to show that AD is equal to AE. So these two sides, the two lines which we have drawn inside the triangle, those two lines should be equal to each other. That we have to prove. AD is equal to AE. So now based on this particular data, we will consider triangle ABD and ACE. That is this particular triangle and this particular triangle. So we'll draw that triangle like this. So we are considering this triangle ABD and this particular triangle AEC. So these two triangles we are considering, where AB is already getting equal to AC, and they have given that BE is equal to DC. Now we will try to prove this particular two triangles ABD and AEC are congruent with each other, so that we can straight away conclude that AD will be equal to AE. So consider here, we will consider triangle ABD and triangle AEC. So in both this triangle, AB is equal to AC and angle ABD will be equal to angle ACE. Both of this because these two are both of this because ABC, so triangle ABC is an isosceles triangle. Since ABC triangle is an isosceles triangle, this AC will be equal to AB will be equal to AC, and according to theorem 7.2, opposites angles should be equal in an isosceles triangle, that is ABC and ACB should be equal to each other. So in this triangle it will be ABD and ACE. So that means ABD and ACE both are getting equal to each other, and AB is also equal to each other because total triangle ABC is an isosceles triangle. So now we have to prove BD will be equal to EC. So how to prove BD is equal to EC? Here they have already given BE is equal to DC. So in the data they have already given BE is equal to DC. So BE means it is BD plus D. So that is BD plus DE will give you the total line BE. So that means in the place of BE I can write this as BD plus DE because D is lying in between B and E. Similarly here E is lying in between D and C. So DE plus EC will be equal to DC. So in the place of DC you can write DE is DE plus EC because E is lying in between D and C. So here DE and DE are common. So BD plus DE. So this DE you can bring to LHS. So it becomes minus DE, which is equal to EC. So plus DE minus DE gets cancelled with each other. So BD will be equal to EC. So that is this particular side BD is equal to this particular side EC. So now we have AB is equal to BC, and here angle B is equal to angle C, or you can consider angle ABD is equal to angle ACE. So these two is possible because since triangle ABC is an isosceles triangle. So because ABC was an isosceles triangle, these two sides became one side and one angle has become equal to each other. Now we have proved that BD is equal to EC. So this has been proved. So because here one side, one angle and another side are getting equal to each other, that is side angle side are getting equal to each other. So therefore, according to SAS axiom, triangle ABD is congruent with triangle AEC. So because ABD is congruent with triangle AEC, here AD will be equal to AE. So that is this particular side AD will become equal to this particular side AE. So AD is equal to AE. This is because triangle ABD is congruent with triangle AEC. So this is what they have asked in example 6 and we have proved that. So this is all there in this particular video. In my next video, I'll be teaching the exercise 7.2 questions. So until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.